Good morning, children. Hope you all saw the marks that you got in the test of sound chapter. As I had given the remarks, I hope you identified your mistakes. You were able to find out your mistake, and please try to work out those things so that you don't make that mistake again. Okay. So I just thought of giving a quick overview of that. Now, most of you, okay, first one, name the waves that can be produced in all three medium, longitudinal wave. Now, give two properties of those waves. Now, already this is given that these waves can be produced in all three mediums. So, please don't, that won't be considered as a property. Apart from this, you have to give two properties. Okay, so the two are they travel as compression and rarefaction. Second one, in them the particles of the medium vibrate in the direction parallel to the direction of propagation of wave. Those two are the properties. Now this one, temperature on 25th, 42 degree and 38 degree. Now when it is talking about temperature, please don't consider humidity. You only have to see the temperature and decide on which day the speed of sound will be more. Okay, please don't consider humidity in this case. Just see the temperature. More the temperature, more will be the speed of sound. Okay, this almost you all have done right. 4 and 5 almost, because these are direct questions. You all have done it right. Now the major problem was in question number 6, 7 and 8. Yeah, most of you all had made mistake in question number 6, 7 and 8. Now, establish the relationship means derive the relationship between. Okay, so how will you start? So, wavelength is equal to. So we know the formula distance. Speed is equal to distance upon time. Okay, so wavelength is the distance traveled by a wave by the wave in one time period. Okay, in the diagram also we mark lambda is the distance traveled by the wave in one time period. Okay, now distance ka formula, you know, from this, distance is equal to speed into time. Distance is equal to speed into time. So we're going to use that formula here. Speed, or here we take velocity into time period. So velocity we took it as v, and time period you took it as t. V into t. So that's how you get lambda is equal to v into t. The next step you'll write t is equal to 1 upon f. Therefore, another formula you get is v into 1 by f, or v is equal to f lambda. Now, one more thing, whenever you do such derivations, these are called derivations. You're deriving the formula. Okay, you're deriving the formula. Now, it is always important to mention what these symbols represent. Okay, so that's why in your solution also, I had in the solution that I sent, I had mentioned all this, right? It's always good whenever you do a derivation, let the velocity of the wave be v, time period t, frequency f, and wavelength lambda. Then you start your derivation. Is it clear, children? So this is what to be done for sixth question. Then seventh, a source is producing 1200 sound waves in 3 seconds. 1200 sound waves in 3 seconds. Okay, so so if they have given like this, okay, if the distance covered by the compression, find the frequency. Okay, in 3 seconds, how many waves are produced? 1200 waves. First we have to find frequency. Okay, what is the definition of frequency? Frequency is number of vibrations or waves in 1 second. Number of vibrations in 1 second. Okay, so I need to know the number of vibrations in 1 second. In 3 seconds, there were 1200 vibrations or waves. So in 1 second, there will be 1200 upon 3 vibrations or waves or whatever it is. So that will be 400, and that is nothing but the frequency. According to definition, number of waves in 1 second is frequency. So when you write F, you have to write the unit hertz. Is it clear? So this is how you get, first you will find the frequency. Okay, then see the next one. This is one thing I think none of you had got it correct. If the distance covered by a compression and an adjacent rarefaction is 80 centimeter, you know that the definition of wavelength is the distance between two adjacent. So in case of longitudinal waves, we say distance between two adjacent compression or two adjacent rarefaction. Okay, so suppose if you have first you have compression, then you have rarefaction, then you have compression, then rarefaction. So CR. So this is one compression, and the next adjacent compression is this one. So now the distance between these two is called the wavelength lambda. But what they have given is distance covered by a compression and an adjacent rarefaction. Now what they have given is this distance between a compression and a rarefaction. Now that will give only the half of this wave lambda. That's the reason why we write lambda by 2 is 80 centimeter. What they have given is only half of the wavelength, because the definition of wavelength is distance between two adjacent compression. If it is between a compression and rarefaction, it's just the half. Now in transverse wave, it is easy to understand, right? These are crests and these are troughs. Now, distance between two successive crests, we call it lambda. We call it wavelength lambda. Same way, two successive troughs also. Now, if I give you the distance between a crest and a trough, that will be lambda by 2. That is just half the wavelength. Hope you got the concept. Two successive or adjacent crest means lambda. Between a crest and a trough is lambda by 2. Same way, two adjacent compressions is lambda. Distance between two adjacent compression is lambda. Between a compression and an adjacent rarefaction will give you lambda by 2. Many of you had taken lambda is 80 and done, and it went wrong. So cross multiply it, lambda is 160 centimeter. Then the third portion, what you have to find? Velocity. And V is equal to F lambda. So 400 into 160. Now this is in centimeter. You can convert it into meter. So it will become 1.6 meter. So 1.6. So 6 fours are 16 fours are 64, and then 2. So 640 meter per second. Okay. So this is how you get the value of these three things: frequency, wavelength, and velocity. Okay. And the last one. Sound wave A and B are traveling in two different media. So this is not medium A and B. Medium is not named A and B. The sound wave is named as A and B. This is sound wave A, and the other one is sound wave B. Now, for which waves will Find which wave will be traveling faster when A is traveling in carbon dioxide. Sound wave A is traveling in carbon dioxide and this is traveling in hydrogen. So you know that we can differentiate only based on their density. Now, if the numbers were given, then you have to do it differently. Now, the numbers are not given, so you have to just logically do it. Now, first you have to compare the density of carbon dioxide and hydrogen. Okay, you all know hydrogen is the lightest gas. So, density of hydrogen will always be less than density of carbon dioxide. This is a known fact. This is from chemistry basically. Okay, now once you know about their densities, you can say speed of sound in hydrogen will be greater than speed of sound in carbon dioxide. This was less and this is greater. Why? Because V is inversely proportional to square root of lambda. Speed of sound is inversely proportional to the root of density. That's why you get this inverse relationship. So that's why here it is less than and here it is becoming greater than. Okay, so the conclusion is speed of sound in H2, that is sound wave B will be faster. That was the conclusion. Sound wave B will be faster because this is greater than that. Is it clear, children? So this is how you have to decide about this question. If the numbers are not given, just you have to compare their densities and then get this conclusion. Yeah. Hope you got an idea about how questions might come in this chapter. Especially these are called logical questions. Okay, this is the first time you are doing them, so please get used to it. Okay. Now the next chapter that we are going to revise is, I thought of doing the first chapter, but then I thought for a change we'll do reflection chapter. Okay, we'll do chapter number 7, that is reflection. Okay, this doesn't have much logics and all, so we'll have a little bit change in this. So quickly I'll tell you what all you have to study. So coming the coming Tuesday, that is 11th August. Yeah, 11th August, you will be having test on 11th August during Zoom class. Okay, so start studying, and I know this chapter already you have given a test and you're a little familiar with this, so you can you will be able to do well and score very good marks. Okay, don't worry. So what you will start, the first thing is you should know the difference between regular reflection and irregular reflection. Okay, regular reflection, irregular reflection, the difference between both of them. Then laws of reflection, law 1 and law 2. And then straight away come here, characteristics of image formed by a plane mirror. Characteristics of image formed by a plane mirror. Okay, so these 5 characteristics are there. Okay, so as I said, A part is just the introduction. Maybe difference between real image and virtual image, you can go through it. Now the actual thing starts from here, B part. Images formed in a pair of mirrors. But to do this, only if you are able to understand A part, you can do. Okay, so I hope you remember everything. To find number of images, we use a formula called n is equal to 360 by theta, where theta is the angle between the 2 mirrors. Then you have cases here. Okay, so if n is odd, then if the object is placed asymmetrical, then the number of images will be n, and if it is placed symmetrical, then the number of images will be n minus 1. Okay, so on the other hand, if you're getting n as even, for all cases you have to do n minus 1. You don't have to see whether they are symmetrical, asymmetrical, whether the object is symmetrical or asymmetrical. If you get an even number, just subtract it by 1. Okay, 6 minus 1, there will be only 5 images. If you get this n is odd, then you have to go in for this thing. Okay. Now we are going to see two cases: mirrors kept parallel to each other, and then mirrors kept perpendicular to each other. As I told you, usually one of these diagrams definitely come. Okay. So please draw the diagrams and see. It is very important that, so you can go back to the video in which I have gone step by step as to how to form these images. So please see that and do it correctly. Okay. So the conclusion was what? Many images will be formed, but the brightness of images, remote images means distant images, keeps on decreasing because at each reflection some light is absorbed. The conclusion is many images or infinite number of images. This is called infinity. So infinite number of images are formed. Okay, where is this used? Showroom and in a barber shop. Okay, then comes perpendicular mirrors. This is comparatively easier, but same. Please draw and practice. Otherwise, you have to clearly show. You will have three images, two images overlap. So P2, P1, P2, P3 and P4 will overlap here. So 1, 2 and 3 images you get it. Is it clear? So the conclusion is 3 images are obtained in this case. Now geometrically it can be seen that images P1, P2, P3 and object P all lie in a circle whose center is at O. So that's why. So when you draw this, you take a compass and draw a circle first and then draw this mirror, and symmetrically you keep P and then you put dotted lines. Okay, here and here, P1 will be here, P2. So they all will be formed on the, they'll be touching the circumference of the circle. So first you can make the images as usual. Look at the, mark the position of images, then you draw the ray diagram. Okay, so that you get a right one. Okay, then uses of plane mirror, you all know to study, what to study. Yeah. Then you go to spherical mirrors. So as usual, the definitions, just go through it. Okay, so they don't ask definitions, but yeah, so you know that there are 7 ray diagrams for concave, case 7. Okay, 7 ray diagrams for concave and only 1 ray diagram for convex. Okay, so all you know how to do. Practice it again. 2 centimeter from P to F2 to F to C, 2 centimeter, and do not take it very much curved. Take it a little bit curved, then you get the right image. Okay, and then what will happen if as the object is moved, how the image changes. Then this table gives all the characteristics. So you can have questions based on characteristics. So it's like draw the ray diagram for image formation by a concave mirror for the case where it forms the same size image or it forms a magnified image. Pay attention. At infinity, diminished to a point. At very far distance, highly diminished. See, note the words. They all make difference. This is just diminished. This is highly diminished. And this is only diminished. So if I ask you, draw the ray diagram for a concave mirror when it forms a diminished image. So you should only draw this one. Don't say, ma'am, here also diminished, here also diminished. No, here it is diminished to a point. Very, very small. Here it is highly diminished and here it is just diminished. Okay, same way, same size, magnified, and this is highly magnified. Okay, if we ask highly magnified, you have to take object at F. Okay, then for convex, you just have 1 ray diagram. So I have also shown what will happen if you shift the object forward. If you shift the object forward, the image will also come forward and the size will increase. These conclusions are important. Okay. The image is virtual. As the object comes closer to the mirror, its image shifts from focus towards the pole and size increases. These two conclusions, conclusion number 1 and conclusion number 2. So the question can be, what happens to the size and position of image formed in a convex mirror when the object is brought towards the mirror. Okay, and there's a special case. There's a special case, that is when object in front of convex mirror is at a distance equal to focal length. The image is exactly at the midpoint between pole and focus. Okay, if it is exactly, if you have taken this as 2 centimeter focus, and you take your object also at 2 cm. Actually, you can take it anywhere in front of the lens, mirror. Now, if you specifically, if this has been 2 and you purposely take this at 2 centimeter, then you will get an image exactly between P and F, means at 1 centimeter it will be formed. Is it clear? So that's the conclusion that we are giving here. Okay, then thankfully this numerical part is cut, so happily you can cut off this whole portion. This was the most toughest thing in this chapter, so you can just cut it off. So this part is completely cut off till this. Then you have uses of spherical mirror, and that also study in detail in case of shaving mirror, where the object should be kept. Okay, concave mirror is held near the face. So specifically they ask, when it is used as a concave mirror, where should you place the object? Face should be between pole and focus. When it is used as a reflector, where it is placed? Doctor's head mirror. So you need to know this, and this is a very important use. How is a convex mirror? Why is it used as a rear view mirror? So I have given marked 3 points. Study on the 3. With this, the chapter is over. As I told you, you can cut off all these example numericals. Okay, and also this whole exercise can be cut off. So this chapter is going to be comparatively easier, and I expect that you would score much better marks. Okay, children. So with that confidence and hope, I want you to start your preparation. Now, one more thing. That day during the Zoom test, there were some children, I don't want to take your names, you had purposely frozen, in the sense you were doing something else in the background. You're in the video, I can see your face, your picture is frozen. That means your movements are not seen, but at the background you're doing something else. You opened a Google and checked or something. Okay, so that means you're doing some cheating. I don't want to accept any explanations that ma'am, this problem, network problem and all that. Only for the children who try to cheat, network problem will be there. Others, they didn't have any problem. So please don't do this. Whatever you know, please write. That's fine. Don't ever try to cheat. Okay, all the best for your test on Tuesday. Do well. Thank you so much, children.